In this video, we will look at how to get started with writing Python. Now, in this class, we're going to use whatever IDE you want. However, the one I suggest is what's known as Anaconda. And you can get to there by going anaconda.com. And under here, you'll see products. Now, don't worry about the pricing as you see there, but if you go to individual edition, that's the one that we're looking at. So the individual edition is open source and it's free to you. So this is a toolkit that contains multiple pieces of software such as Spyder IDE, Anaconda, certain packages that you're going to use mainly in graduate school or in your senior level courses here. So if you scroll down under downloads, you'll be able to see all the different types of downloads that you have. There's 2 for Windows, 2 for Mac. Now, generally, everybody, 32-bit is probably went out in 2005, 2006. So if you have a relatively new computer within, say, 2010 or so on, then you probably have a 64-bit computer. And so generally, except for Windows, I guess everything else is 64-bit. If you have a Mac, you're looking at the graphical installer. I would just recommend the graphical installer because it'll lead you through installing it. Unless you've dealt with computers before, then you can use command line installers. But generally stick with the graphical installers and then you'll be good from there. Whenever you do that, it will automatically load in this tool, which is called Spyder IDE. Now, Spyder IDE gives you essentially a lot of different options, a lot of different windows and things like that. So if you click view, you'll see all of the different panes that you can do. So in here, we have the editor, the IronPython console, which is this down here, variable explorer, which is this right here. And then you have your editor over here on the left-hand side. You see, whenever we write Python, we actually write in kind of like plain English, except the English has a certain syntax to it known as Python. And this is how Python can understand things. So if I'm over here and I do something like print hello, the syntax is that print comes first. Notice it changes it orange. This is what's known as syntax highlighting. And this is very nice because if you come from like C or C++, a lot of times we type printf, stands for print formatted, and notice it doesn't colorize. And you're like, wait a minute, did I do that wrong? Yes, you did, because in Python, it's just print. The syntax also says that you will provide arguments using parentheses, just like we did here. So notice this little star next to temp.py. The .py stands for Python, and that's the extension for Python source code files. So I'm going to save it, click up File, Save, or you can hold down Control and press S, or if you're on a Mac, it's Command, press S. Now you can see that star goes away. So the star tells you that the changes have not been saved. Now what I'm going to do is I'm going to run it, and you'll see it pop up over here on the console. So under Run, I'm going to click Run, or you can hit F5. So when you do that, it prints out hello. So this is just a little debug statement showing you what's actually happening. It's going to run C:\user Sean T's Spyder, Python, temp.py, that sort of stuff. So it's going to execute that command. And then what it's going to do is it's going to run our temp.py right here. And then as you can see, it runs it. Now also inside of here, it's what's called an REPL. A run, evaluate, print, and then loop. So what I can do here is I can actually type Python code as well and see what it does. So if you're experimenting with Python code and stuff like that, you can just come to the console and say A equals 10, A equals 10, print A. And you can see it prints out 10. Notice whenever I did A equals 10, it created a variable and it pops up in the variable explorer. However, if you're writing your labs and things like that, you actually want to write them into a .py file because this you're not going to be saving. Now, there is a way you can copy and paste it, but generally what I recommend you do is write your Python over here on the left-hand side and test it, save it, and then submit that. But this allows you to do something like, I want to try something small with Python to see how it would work. So for example, if I did A equals 10 divided by 3, I'm not exactly sure what data type this is going to give me. So I can print type A and it gives me, it's a float. So these are just the little things that you can do inside of this console and just print out certain Python code to see what it does. However, the actual code to get something running to solve a problem will need to be over here on the left-hand side. So that's essentially whenever you install Anaconda, you're going to get this Spyder IDE. Once again, your source code's on the left-hand side, your variable explorer. You do have to click variable explorer down here. I think it starts with help and gives you this little usage prompt, but you'll click on variable explorer and it'll show you, okay, here's the name of it. We call it A. It's a float and there's only one of them inside there and its value is 3.0. So you can see as A changes, so if I do 2.1, it's still a float, but now it changes to 2.1. If I change it to 1, you can see it goes from a float to an int and gets the value 1. Or if I do a equals 1, 2, 3, it's now a list and it has the value 1, 2, 3. The size is now 3. It has 3 elements inside of it. So these are the way, and you'll learn all about lists, how these sort of things work, that sort of stuff, a little bit later. But I just want to make sure that you can set this up, because this is where you're going to be programming most of the time and testing your code to be able to submit it. Now, this is what we do instead of zyBooks. Now, zyBooks is an online textbook. It will change in the future. So if you're watching this video and you have no idea what zyBooks is and you don't see it on Canvas or something like that, I've already moved away from it. So zyBooks is an online textbook that you'll be able to see and do some coding examples in. However, the new textbook is a lot more beginner friendly, and it will step you through code and give you some pretty interesting projects that you can help design. And in the future, we'll see what we can do about getting those assignments. So a lot of your assignments now will start with zyBooks, but then you'll start having to program in here and submitting those for like a TA to grade and stuff like that. So get familiar with this, start playing around with it, seeing how you can type out Python code. If you ever see me do it like in a video or on the lecture notes or something like that, type it out. Copy and paste it, figure out what each line is doing, and then you can step through it. The nice thing about this is it comes with a debugger. So if I go into debug and press debug, it's going to run the debugger. And as you can see, when I highlight over here on the left-hand side, there's this little red mark. That's what's known as a breakpoint. So I'm going to print hello, I'm going to print worlds, and I'm going to print quit or something like that. So it just prints 3 things. Now I'm going to move the little red mark down to 3. And see what happens. So now what I'm going to do is go to debug, debug. So notice it prints hello, but it stops at world. So that's what that little red mark means. It's called a breakpoint. It says stop here if you're debugging, and then we can figure out what's going on. So notice it skipped hello, but now our line is at world. So I can type continue, which is just lowercase c, and it prints out the rest of it. So getting used to the debugger, there's a lot of information under help here. There's actually a tutorial under Spyder tutorial. I'm not going to cover most of that sort of stuff here because this class is all about writing Python, not actually how to debug your code and stuff like that. But debugging your code can go just by simply printing out, and you'll see I do this during your lecture videos and things like that, is, okay, let's print out the type just to make sure that we're 100% aware of what's going on. So if I do something like this, a equals 10, b equals 20, c equals a divided by b. Now we can see that is a divide operation. Now if you're not familiar with it, the / says a over b, and in Python that will be division. However, there are 2 divisions, and if you don't remember which one it is, well, we can sort of debug right here. So I'm going to debug and see what we get. So once again, we go over to debug. So run will run past them. As you can see here, it just runs right past it. You have to go under debug and debug. Then it stops under there. And then I can do a next instruction. As you can see, it runs the next instruction, c equals a over b. When I run next, it's going to return because there's no more instructions here. So as you can see, it gets me back into the console, and now our program is actually done. So you can see up here in our variable explorer that a divided by b actually gave us 0.5. So 10 divided by 20 is 0.5. But as you can tell, we have int, and a float. So that's integer, integer. So that's the integer portion of a number. Integers do not store decimals, as you'll learn whenever you get to variables a little bit later, next lecture after this. So, and then in there, you can see we have a float. Float means floating point, means we can store a decimal. As you can see, it stores a decimal. So these are the sort of things that, if you're not familiar with Python, it's best if you step through your program 1 instruction at a time. So whenever you do a equals 10, make sure that a legitimately gets the value 10. Whenever you do something like this, so I see a lot of students do this, where you do a input, enter a number, b equals input, enter another number, and then you print something like a divided by b, and then you print c. So I'm going to run this without the debugger, and you'll see that it doesn't actually work. So we do 10, 20, and it says type error. And so we're like, wait a minute. Now with the variable explorer, you can see what's going on. You can see 10 and 20 are actually strings, and then you can't divide a string by a string. So it's like, okay, what are we doing here? So I can break it here and go to debug. And I'm going to do next. It just says run 1 instruction and stop. And it says enter a number. As you can see, now we're stopped at B, the second line. I can do continue, and that's going to run to the next breakpoint. But as you can see, I've got no more red marks over here. I can add one under print, and then it's going to continue to the next breakpoint. Okay, as you can see, we never actually got to that breakpoint. So if you're confused and see where it is, now it's kind of easy because it tells you line 4. And notice that the cursor turns to a finger. If I click that, it moves me directly to line 4 and says, fix this. Okay, so in this case, we now know the reason that this isn't working is because if we look over at the variable explorer, it tells us that both of them are strings. So let's convert them to ints, and let's see what happens now. So I'm going to debug. We're going to go next, enter number 10, next, enter number 20. Okay, here's the next command. Let's see if it works. Oh, look at that. C gets a float, 0.5. We hit continue, and notice we get 0.5. Now, one of the things is, know that A and B are still strings. So this int right here, as you'll learn, temporarily converts those into integers. So it actually converts the string 10 into integer 10. But since I'm not saving these results, it's only used for this division. So if I was to come down here and do A divided by B again, it's not going to work. So I'm just going to run this, and I'll do 10 over 20. And as you can see, line 5 this time, which is D equals A over B, no longer works. Why? Because this temporarily converts the data type into an integer. So there you have it. That's how you're going to load these programs. Now, as you can see, temp.py, that is the program that you're going to have. And these are whenever you get into the canvas and you try to upload your file, it's going to have to be a .py Python script file. And here's what we're going to do. We're going to actually run these on our local machine. Now, you probably don't know what this does yet, but you will see this at the bottom of a lot of the sample code that I give you. Okay, so the reason I have you do this is the cool thing about Python is you can import, and that's what we're going to do when we grade your code. You can import Python code as a module. So in this case, I can run my own Python script that grabs your entire source code, imports it as a module, and then I can run portions of that. So that's why it's important that if I give you a function name, you use that function name. Otherwise, it's not going to work whenever we try to grade it. And so this is important because if you import a module, it's going to run the Python file. So what this does is instead of running it, it just copies all of the functions, defines them all. That way it's sitting there ready for us to test your file. If you don't include this, once again, it's going to run your program. And the data that we give it might not even get into your program. And so it's not going to be really that gradable, and you'll probably lose points for doing that. So always make sure you have this. Every single time I do like an example, you will see that if name equals main shows up all the time. Okay. So in this case, there we go. There's if name equals main. So this is your Python code. This is just sample code that I'm going to give you. And what I would recommend is that you copy and paste this into Anaconda. Anytime you see code like that, you're trying to learn what it does. Hey, just copy and paste it. As you can see, here's name equals main. Okay, it's going to call what's called main. Well, it's defined right here. So now let's see what this does. It says enter the numerator 10, enter the denominator 20. Result is 0.5. Okay, cool. Well, that seems to work. And so make sure that you can run it and see what's actually happening, because just reading it like this, unless you really know Python, you're not going to know what it does, or at least you're not going to know it well enough to be on your own. So what's going to happen in the future is you will get template code in which you will modify certain portions of the code that I've already given you. Then slowly but surely, the template will start becoming smaller and smaller, and then you will have to contribute more and more. And then the very last problem, there is no template, and you will have to contribute the entirety of the code. So we're working you up into incrementally getting to the point where you can start a program from scratch, where you go to this IDE, there's nothing there, and you can start typing out code to solve a problem. That's how it's going to be for your final problem. However, for the first couple of labs, you'll get code that you'll need to copy and paste or type it in and understand what it's doing. So what I'd recommend, if you get a template, type it out, see what it's doing first before you start entering your own code in there. And once again, you have this debugger right here where you can see, okay, where did things go wrong? You can step through it one instruction at a time, look at the variable explorer and see what's happening. So those are the ways you will be able to write your programs, and to do it in a way where you actually can see the results of each line of code. One of the biggest things that most students do is they'll just sit down, they know there's a deadline, and they'll just start typing out all the code, especially if you're late. If you didn't get started early enough, you just sit down and start writing code. And debugging that code, especially if you're not familiar with Python, is going to take a lot more time than if you just wrote one line of code, debug it, see what it did, write the next line of code, debug it, see what it did. And to do that, you'll need to use what's called pseudocode. And I'll give you some tips later in the semester on how you can actually write out code or pseudocode or write it out in English so that you can actually understand it. And essentially, you become a translator. I'll give you like word problems, like a math problem. And you're like, okay, I know how to do this in my brain. You write it out, all the steps that you would take to do that. And then what you do is you translate into Python. Python's waiting for your instructions to do what you want it to do. So there's a lot of things that you have to keep in mind. There's a lot of things like, okay, which division am I going to use? Is that an integer? Is that a float? Things like that. With the computer, there are certain aspects of the computer that will change your results. If I divide one integer by another integer, I lose everything to the right of the decimal. You have to know that the value does not round, it truncates. So for example, if I did something like a equals 1, b equals 2, and I do c equals a divided by b, print c. So that's integer division, a divided by the 2 division sign here. If I run it, notice we get the value 0. So it truncates. It's supposed to be 0.5, but because c is an integer, it can't store anything to the right-hand side of a decimal point. So therefore, we get 0. If you didn't know this, and you're running your code as if it didn't do that, it'd be almost impossible for you to debug this. You'd be like, why am I getting 0? It should be 0.5. However, if you know in the back of your head, and you start stepping through this line by line, that's where this variable explorer is going to help you out. You're like, okay, I know that's an int. I know that's an int. This should be a float, but it's an int. I used the wrong division. I need to use the 1 division sign. And notice now it's a float and it gave us 0.5. So that's why it's important that you understand how this is going to work, how Python is going to work, because it just does what you tell it to do. So that is Python source code over here on the left. Once again, your variable explorer over here. Once again, if you start the Python ID or the Spyder ID, it's probably going to be in this help. You'll just need to click over here on variable explorer so you can see what's going on. And then your console is down here. Once again, you could do things like type hello to see what type that's going to be. It tells you it's going to be a string. If you want to type out something like A, B, it's like that's a set. Or if you type something out like A, B, that's a dictionary. So you'll learn what all these different data types are a little bit later, but I just want to show you that you can write small lines of Python code just to see what they do. So if you see Python code inside of your lecture notes or in the videos or something like that, test it out, see what it's actually supposed to do. And then now that you've done it, now that your hands have done the coding and you've seen the result for yourself on your own computer, it helps it stick in your mind. Okay, now I know what that's going to do. So there you have it. Running this, now you have infinite compiles. You can run this program as many times as you want. And that's the thing is, don't be worried. You can upload rough drafts, and then whatever the last draft is that you submit, that's the one we're going to grade. So don't worry about it. You can upload what you think works, test it, start putting some polish on it. So just like what you're going to do in English, like you did in high school, middle school, things like that, you start with a rough draft, something that gets around to solving the problem. And then you're going to add some polish to it, move some code around and get it to work more effectively, more efficiently, and then 100% solve the problem. Once again, we only grade whatever the last one is that you submit. So you can have 10 submissions, and then that 11th submission that you submit, your last one, that's what we grade. We completely ignore 1 through 10. So that does bring up another interesting point, is that a lot of students are like, hey, could you grade number 3? No, we only grade the latest. And so there you have it. You've got all the tools that you need to actually learn Python and use Python to solve these problems. So once again, you will have homework that just basically has you acting like the machine, acting like Python. So you can step through Python and tell me what is it going to do. And that's your chance to see what Python actually does. So for example, if I just had this code and I did not have the ability to run it, you should be able to tell me what this is going to do. A equals 1, B equals 2. Well, this is 1 divide, so I know that's not floor division, so this will give me a float, C, that's equal to 0.5. And those are the sort of things that you should get used to doing. Stepping through Python, making sure 100% you know what everything is doing. So just like we did with the debugger, step through it one instruction at a time, see what it does. And that is going to help you tremendously to learn Python. The more you do, the more you're going to learn. So there you have it. Welcome to COSC 111, 505, or whoever. We might have changed the numbers by the time you watch this. But whomever you are, welcome. This is how we're going to learn Python. Stick with the course, and you'll learn Python and be better for it. Thanks for watching.